That one for now. So, if you want your presentation slides to be error-free, use spell checker, don't you? And that's what I did here, and the spell checker somehow didn't complain. Maybe you can help me and proofread this. Do you see any errors with that? Yeah, right. So that is not correct, and other problems? Yeah, right. So for those who didn't see it, whoops, I'm skipping a slide it seems. So this one, that was spelled wrong, and yeah, it always skips 2 slides, and pigeon was wrong. Oops. So you probably knew that spell checking won't find all the errors you make. And we've been working on a solution to that, and you can try it on LanguageTool.org, where when you paste these 2 sentences into the form and you check them, it will find both these errors, and it will also make proper corrections. And that's what this talk is about, what comes after spell checking. Here's a short roadmap of the talk. First, I'll explain how we use LanguageTool to find a million errors in the Wikipedia. And then I'll explain how LanguageTool works internally. I'll explain what approach we are using for LanguageTool and what other approaches could be used for style and grammar checking and why we are not using those other approaches. And then I'll make a suggestion how we can start fixing these million errors we found. Finally, I'll then talk about the future work we are planning for LanguageTool. First, a small survey. So how many people of you here have heard about LanguageTool? Okay, not so many. How many have actually used it? Not so many. Okay, that's why I'm here. So how do you find a million errors in Wikipedia? Basically by running this command. LanguageTool wikipedia.jar, it's actually not part of the standard LanguageTool distribution because it's kind of very specific. Checking the Wikipedia is not what the average user does all day. So it's part, you need to download the nightly builds to get this command. And then it takes 3 parameters. Check data means like check an XML dump from Wikipedia, and then you specify the path to that XML dump, which is several gigabytes in size. And you specify EN, which is just a language code for English. And then it will start, and it will give you results like this. So it will print the title of the article where it thinks it found an error. It will give the location of the error, and it will give you a message and the error with some kind of ASCII underline. And in this case, you can see there's an error. It says will designated as, but it should be will be designated as. And so LanguageTool actually found the problem, but the message is a bit off. So the suggestion is not quite correct, but at least it found the error. So if you run this command, you get a lot of these errors, a lot of this output. Running it on the English Wikipedia takes about 10 milliseconds per sentence. But because the English Wikipedia is so very large, that would take about 1 week or so on my computer to run through the entire Wikipedia. So what we actually did was we ran LanguageTool on 20,000 articles, which led to about 37,000 potential errors. So what's an error now? For the sake of simplicity, I will just talk about errors when I mean grammar errors or style suggestions. It does not include simple spelling mistakes that a common spell checker could find. And if you project this number of 37,000 potential errors to the whole Wikipedia, which has more than 4 million articles, you get 8 million potential errors. And of those, we selected 200 randomly and checked them manually to see how many of these projected 8 million errors would actually be useful. So how many of these are actual errors. And the result is that in the whole Wikipedia, if we ran LanguageTool really over the whole Wikipedia, you'd get about 1 million errors that are actually useful. And as I said, that does not count simple spelling errors because we have turned them off. It's just there are too many proper names and so in Wikipedia you'd get too many, even more false alarms. So still, we have 8 million potential errors and only 1 million useful errors. So it's kind of like too many false alarms, you might say. And there are several reasons for that. First, it's surprisingly difficult to extract text from the English Wikipedia. They use this MediaWiki syntax, and one problem we have with that is currently we cannot expand the templates. So you have a text like an elevation of about 115 meters. That's what you see when you read the Wikipedia. But in the wiki syntax, it has this template syntax, and we currently cannot expand this, so we only get an elevation of about and then a space. So that will, of course, in several instances confuse the grammar checker. You also have, as an encyclopedia, obviously many place names and movie titles and any kinds of names in your text, and also non-English place names, and that's also difficult for some kind of proofreading tool to handle. You also have cases like articles about math, where you have sentences like the value of n for a given a is called something. And here the word a is used in two different meanings. The first one is the determiner, as you would expect, and the other one is kind of a math symbol. And as LanguageTool is not optimized for articles about math, that will also confuse LanguageTool. Now, if you use LanguageTool or any proofreading tool on articles that have already been checked quite well, you will obviously get more false alarms. And most of the articles in the English Wikipedia have already been checked. Also, our English rules still need to improve, so we get less false alarms. So here are some examples of the bad matches, so not so useful matches that you get. It says 68,000 assembler in the text, and LanguageTool suggests to use assemblers, the plural form, because it doesn't know that 68,000 assembler is actually a kind of a product name here. Or you have cases like score voting and majority judgment allow these voters. And LanguageTool incorrectly suggests to use the third person singular, because here the reason is that the detection of the noun phrase doesn't work properly. So in this case, LanguageTool only detects majority judgment as the noun phrase, and not score voting and majority judgment. So that leads to a false alarm. And finally, this example from the math article, where it suggests to use n because the is starts with a vowel sound, and usually, if that is the case, you use n instead of a. But of course, here are some useful matches. In a vote of 27 journalists from 22 gaming magazine, LanguageTool suggests to use magazines, the plural form. Okay, the next one is easy. This just flows through the body. It suggests to remove the duplication. And sending back their work to the teacher's computer, it properly detected there's an apostrophe missing. Here's an example for a style alarm you might get. If you write something like there are many different variations, LanguageTool suggests to use just many. That's because variations kind of implies the different already. And whether you agree, of course, with these style suggestions, it's kind of up to you, whether you consider these useful. So some examples of errors which we cannot detect. These are not from Wikipedia now, I made them up. So we cannot detect semantic problems, of course, like Barack Obama is the president of France. That won't trigger any error. If you write something like, I made a concerted effort, your English teacher will tell you that concerted implies more than one person was involved. So that's not correct, but we won't detect that now. And if you write a sentence like, tomorrow I go shopping, it should be tomorrow I will go shopping. That's also a case which we don't detect yet. Now you could write rules maybe for these, but they would be very specific. I will talk in a few minutes about how to write rules. And then you will probably see that you could write rules for these cases, but it's doubtful if it's actually useful. So here's a short overview about LanguageTool. The basic idea of LanguageTool was always to be the next step after spell checking. So we don't replace spell checking, but we kind of run after spell checking. And nowadays, we actually have one component that does a traditional spell checking. We have that component inside of LanguageTool. The project was started in 2003. It's released under LGPL. We have about 10 regular committers now, and we are on a time-based release schedule with a new release every 3 months. And everything is implemented in Java and XML. You'll see in a few minutes why we use XML, or what for. So as a user, how to use LanguageTool, you can use it either as a command line application or on the desktop. We have also several extensions for LibreOffice and OpenOffice, Vim and Emacs, and Firefox and Thunderbird, and even a few more. If you're from the Java world, you can directly use our API. And if you're using some other language, then you might use our embedded HTTP server. We also have an HTTPS server, which returns some very simple XML, which you can then pass to see the errors in your text. Now, how does this work internally? LanguageTool takes plain text as input. It then finds the sentences in this text, and in these sentences it finds the words. And for each word, it analyzes the word. For example, it finds its base form. For walks, you will get the base form walk, for example. And you will also find the part of speech text for each word, which can be ambiguous. For example, in the case of walks, you would get, it can be a plural noun, or it can also be a third person singular verb. Now we have this analyzed text, and then over this analyzed text we run some Java rules, but most importantly we run over that some error detection patterns. These patterns are kind of the core of LanguageTool, and I'll now explain how these work. The basic idea behind these error detection patterns is to be first simple, so you don't have to be a software developer to contribute new rules. And the other idea of patterns is that they are all independent. So even if you add a new rule, you cannot break any of the existing rules. That's often unlike in software developing, where you change something and something else breaks. Here's an example of a slightly simplified example of a rule. Rule always consists of two parts. The first part is the pattern itself. So first I should say that error detection patterns, we internally call them rules. So a rule consists of those two parts, the pattern itself and a message that is displayed to the user when that pattern is found in a sentence. And the pattern again is just a sequence, in the simplest case it's just a sequence of words. So in this example you have the token bad, and token is just a technical term for word, followed by the regular expression English or attitude. So this pattern will just match the example from the first slide, bad English and also bad attitude. And in the message, you then can see that back reference, it will just use that \2 to replace that with English or attitude. So the user gets to see the message, did you mean bad English, for example. Okay, that was a very simple example. Other things you can do in your rules are you can use logical and or, you can use negation, you can do skipping, like match a word, then skip over n words and then match another word. Or you can use inflection, that means do not just match the word walk, but also all of its forms without writing them all down. For example, for walk, it would match walking, walks, and walked. And you can match part of speech patterns, like match all verbs, or match only all third-person singular verbs. And that's described on our wiki in detail. Okay, and because this is kind of the core of LanguageTool, I give you one more example. This detects the error in always I am happy. That's actually a mistake that a non-native English speaker might make. And I'm taking these examples, as you can see, from the bottom of the rule, because at least 2 examples are part of the rule. One example needs to be incorrect. That means it needs to match the pattern above. And the other example needs to be correct, so it must not match the pattern above. We use these rules, these examples inside the rule for our unit tests. And it also makes it easier to understand what the rule actually does. So this rule has some kind of first token send start, which just means match only at the start of the sentence. And then it has a regular expression again, always, hardly, or never. And then it has a token with an exception, which means that it will match all tokens except those. And those are those VB, MD, and JJ. VB means verb, any kind of verb. MD means modal, and JJ means adjective. Now, if that sounds confusing to you, we didn't make these up. These tag names are actually standard in computational linguistics. It's called the Pantry Bank tag set, and that's what we use here. Now we have these kind of rules for 29 languages, which technically means we support 29 languages, but we support them to a very different degree. You can see here, I guess if you cannot read this, the languages with the most number of rules are French, German, Catalan, Polish, and then comes English. So French, for example, has more than 2,000 rules, and there are other languages like Greek and Japanese that have less than 100 rules. This means that, although this is only a very rough indication of how good a language is supported, it's an indication that, of course, if you switch LanguageTool to Japanese or Greek, it will not work that well in the sense that you will not find so many errors. So that means we will have to do a lot of work here for those languages with lesser rules to get a better coverage. So what we do is basically pattern matching. And you might wonder, language is kind of complicated. Is pattern matching really enough? Or ask in a different way, why don't we use a more powerful approach? So let's take one step back and ask, what is grammar actually? Grammar is a set of rules that describe how valid words, sentences, and text look like. And syntax is a part of grammar that is a more or less formal description of how a valid sentence looks like. And you can also ask, what's a parser? A parser is something that takes a sequence as input and generates you some output structure, typically a tree, for example. And you know this from software development, where we do this successfully for decades. And so you might ask, why don't we just do the same for English? Why can't we just write a parser like we have a parser for Python or whatever? Why can't we just write this kind of parser for English? So it turns out we kind of could, but that's not the approach we are taking in LanguageTool because it's just so very difficult. So there is no formal description of the English grammar, but if you look in a comprehensive grammar book, you you'll find that and you consider this to be some kind of specification, you'll find that it has 1,700 pages. And even if you say now, okay, this is just English is kind of special or complicated or whatever, and you look at a constructed language like Esperanto, which should be much easier, you still have a specification, if you want to call it that way, of about 700 pages. So that's complicated. Also, if you write such a parser, you will more or less end up with a parser that's probably specific to your language. And we want to support more than one language in LanguageTool. Even more reasons why it's difficult to use a parser to parse English. Having a parser does not automatically mean that you have good error messages. So you basically, even if you have your parser, you need to go one step further and optimize it to get useful error messages, because otherwise you'll get parser messages like, I cannot parse the sentence, which is not useful to the average user. And even if you have done all that, you're still not finished. Because if you look at sentences like, sorry for my bad English from the first slide, it turns out that it actually parses fine. Because bad English could also be some noun phrase. Sorry for my, and then some noun phrase. So technically, sorry for my bad English is a grammatically correct phrase. So there are parsers actually like this. For example, there's Link Grammar, that's also open source, and it's used in AbiWord, an open source word processing software. So you can go this approach and try to write a parser for English. But it's difficult. And because we from LanguageTool want to support a lot of languages, that's not the approach we are taking. But I'm not saying it's bad or something, it's just difficult. You might also wonder, why don't you use machine learning and statistics and so on? First, we do use Apache OpenNLP for finding the chunks. And chunks is another name for phrases. So Apache OpenNLP gets us the noun phrases and verb phrases. And that's based on a statistical approach, which has been trained. And we use it as a kind of black box to find those phrases. However, if you want to use a statistical approach or machine learning or whatever to actually find the errors in a text, you'd need some large corpus where all the errors have been annotated. And then you need probably another large corpus where you know this is free of errors. And then you could maybe come up with some kind of training to get a model, and then you could use that. But it's not so easy to find these annotated errors. You'd have to annotate a lot of errors. And while the situation for English is quite good, you get a lot of resources, and the English Wikipedia, for example, is huge. But we also want to support languages that have not so many resources, so that's kind of difficult. It's difficult to use machine learning. But again, I'm not saying that this is a bad approach to use this. If you have some idea how to use machine learning to proofread a text automatically, feel free to do that. And even then you can kind of plug into LanguageTool, which is by writing your own rule in Java. And that works like this. You only simply implement one single method from the rule class, the match method. And it gets as input an analyzed sentence. And that's what the class name suggests, is a sentence with its tokens, and the tokens have their analysis. So they're base forms and they are part of speech tags, and then you can do with this whatever you want. You can run any logic you want. And you could even actually ignore our analysis of base forms and part of speech tags and just look at the original text. And if you think you found some match, then you create a rule match and thus just return that. So that's quite easy to integrate into LanguageTool. And if you do this, you get all the stuff we do for free, like the graphical user interface, the command line interface, and the extensions. So it's surely better to plug into this mechanism than to start writing your own grammar checker, where you would have to write all the plugins from scratch and so on. So now you have some overview about how LanguageTool works. But we still have that million errors from Wikipedia. Now how do we fix them? Well, as I said, we do not really have 1 million errors in our database because first we are only running on a small virtual server, and the second reason is I think having 1 million errors actually listed in your database is kind of overwhelming, and it wouldn't probably motivate anyone to start fixing those. I mean, who wants to work on a to-do list with 1 million items? So what you can do is you can have a look at community.languagetool.org, where we list a few thousand errors, and if it's a false alarm, you can log in and mark it as a false alarm, and if it's not a false alarm, you can actually click on a link that I'll show in a minute and fix the problem in the Wikipedia. So what we use here is checking the XML dumps from Wikipedia. So that's not really a live view. Those dumps are created every 2 weeks or so. Okay, and as we have 1 million errors, that probably won't get you very far. So what I suggest is actually something else. As a first step, we have a new feature where we check the recent changes from Wikipedia. We fetch this atom feed of recent changes twice a minute, and then we run LanguageTool over it. Not over the complete articles, but only about those parts that have actually changed. And then we detect if someone has made an edit that has introduced an error. And we also usually detect whether someone has made an edit that has fixed an error. So what we end up with in the end is we have a database of freshly introduced errors. It looks like this. So you have the error message, and with the blue squiggly underline, the error. Now there are two cases. One case is that it is a false alarm. Then you can click it is a false alarm, or you can just ignore it. But now assume, like in this very first example, it's actually an error. What you can do then is click on the Check Page Now link. And in that moment, we go to the Wikipedia and fetch the current version of the article via the Wikipedia API and run the complete article through LanguageTool. And we will then show you this page, where you can, if everything works well, without typing anything, you can just click on the corrections made by LanguageTool if they are useful and if it's not a false alarm, and then submit that page, and we will send you directly to Wikipedia. So that's as if you had made an edit in the Wikipedia. And you end up in this diff view where you can, for the last time, check that we didn't break anything. And we also conveniently set this edit summary and check this is a minor edit checkbox, because usually it is. It's just some kind of grammar or spelling fix. So this is what I would suggest as a first step. Instead of working on those 1 million errors, which are somewhere more or less hidden, let's start and try to make sure that not so many new errors get introduced in the Wikipedia. Using, for example, this tool. It's not yet activated for all languages, but if you feel keen to actually use it and to maybe optimize it in the sense that you improve the rules or disable rules that are not so useful, then let me know about which language you want to have activated, and I'll try to do that. For now, it's activated, I think, for German, English, and French. So finally, some words about the future work on LanguageTool without walking you through our entire to-do list. What I'd basically like to see, of course, is to become spell and grammar checking ubiquitous. Style and grammar checking ubiquitous, like spell checking already is today. You basically cannot type anywhere being spell checked. And I think we shouldn't stop there. We have now more powerful tools. We can do style and grammar checking, so we should use it. And what's the current state? Well, we do have a stable Java API. We are also available on Maven Central. It's useful for Java developers. We have an HTTP and HTTPS API for more or less easy integration. We have support for many languages. We have a license that I think should be liberal enough for almost all use cases. And we're written in Java, which is an absolutely good thing if your software is also written in Java. If your software is not written in Java, you might not like that. So how can we, despite being written in Java, how can we become ubiquitous? For example, how could we ever run in a browser despite being implemented in Java? So my idea was can't we just compile Java to JavaScript with LLVM? Okay, I tried that and it failed. Too bad nobody replied to my Stack Overflow question, but that's why I'm here. So I'm asking you for help. Maybe you can have a look at that question and answer it. Or even better, after the talk, you can come talk to me and explain to me how this is done, compiling a complex Java application to JavaScript. Of course, we are also happy to get help from people who want to add support for another language to LanguageTool. It's not even that difficult. You can usually start with another language and then write one rule after the other. As I mentioned, we have a lot of languages that are not actively maintained or not actively maintained enough. So here's a list of languages that are really in need of a maintainer. And if you want to maybe maintain these languages, we would be very happy to welcome you. Maintaining a language basically means writing new rules and making sure that the existing rules get improved and that they don't create too many false alarms. You don't have to be a software developer for that, but of course we also welcome software developers. Oh, sorry. So, as a summary, I'd like to say, I think today we shouldn't stick to simple spell checking that totally ignores context. We have more powerful checks available today, and I suggest you use them either as a user or as a developer. And I hope that our style and grammar checking of Wikipedia is kind of a proof that this technology can be useful, despite the number of false alarms. And of course, your contributions are very welcome. You can talk to me after the speech. And that's it from me. Have a nice conference. Are there any questions?
Luke.
How do you detect grammar errors or errors in Japanese without any rules?
Stand up.
Should I repeat the question?
The question is, how do you find errors in Japanese without any rules for Japanese?
We do have rules for Japanese, just not so many. Was that your question?
There's 0 in my database.
I see 0 in the database, so perhaps it's just me.
Okay, maybe in the meantime, some other questions.
We have another question here.
I'm here.
Yes?
Can a language tool cope with texts with some markup, like LaTeX? Or is it possible in near future, let's say, if it's not possible now?
Yes and no. So we kind of push this task to the software that integrates us. So what we demand of the software that uses LanguageTool, that integrates LanguageTool, is to tell us where the markup is. We need the position of the markup, and then we will just ignore it. So if there's some software that can do this, that knows the markup and feeds us the text with including the markup positions, then yes, we can handle that text. But we cannot handle that in the sense like we know, okay, this is now marked up as like a headline, and then we have some special headline mode or so. That's not, we cannot do that yet. More questions? The question about the Java rules was misunderstanding. We have no Java rules for LanguageTool, but we do have XML rules. So the Java rules are just some special cases if you prefer for some reason to write your rules in Java, or maybe the XML-based approach that I showed is not powerful enough, then you can always write your rules in Java. And we have not done that for Japanese. Okay. Any other question? Okay, it seems not. You can come to me now and ask me. Thank you.